Hello everyone, welcome to Learnitor.com. So today we are going to solve the LeetCode problem, which is problem number 950, reveal cards in increasing order. So you have given an integer array deck. There is a deck of cards where every card has a unique integer. The integer on the ith card is deck I. Okay, and you can order the deck in any order you want. Initially, all the cards start face down unrevealed. Okay, in one deck. So you will do the following steps repeatedly until all cards are revealed. Take the top card of the deck, reveal it, and take it out of the deck. And what's the second step is if there are still cards in the deck, then put the next top card of the deck at the bottom of the deck. Okay. And if there are still unrevealed cards, go back to step one. Otherwise, stop. And we have to return an ordering of the deck that would reveal the cards in increasing order. So this is the question. And here they have given one example like the inputted array inputted deck is like this and its output is this, and how they got that output, like when means there are two steps, like take the top of the card of the deck, reveal it, and take it out of the deck. And if there are still in card in the deck, so next top card we have to put it into the bottom. And with these steps we have to find out the ordering, so that when we are revealing the cards, that cards is in increasing order. So this is the output, and how they are getting this output, like means after reordering, this is the output. So 2 is at the top, so 2 we are revealing 2, and then we are, so 2 we are revealing, then we are pushing 13 into at the end of the deck as like this. Then we are revealing 3 and putting 11 at the end of the deck. Then we are uh, revealing 5, then we are pushing 17 at the end of the day, then 7, then means pushing the 13 at the end of the day, then 11, then pushing 17 at the end of the day, then 13, and then at the 17. So through, if you check the reveal, like 2, 3, 5, 7, 11, 13, and 17, so these all are in order, so that will give us the correct result. So that was the correct output. So let's check means how we can solve this code. Okay, so what is the input? I'll just copy that input, copy, and just I'm going to paste it the output. So this is the input and this is the expected output. Okay, so what we have to do is, like, first we can sort our deck. Why we are sorting our deck? Because means we are going in the reverse order. Okay, what they are expecting, so whenever they are returning an order of the deck, that would reveal the cards in increasing order. So I am going in reverse order. Okay, so whenever they are revealing, we need to should be in the increasing order. So what will be the increasing order for this is 2, 3, 5, 7, 11, 13, and 17. Then, okay, and the corresponding indices for this is 0, 1, 2, 3, 4, 5, and 6. So similar thing, I'm just inserting it into my indices double-ended queue. Okay, so that we will get the result, the exact output like this. So what they are seeing now here, so what is the steps they are following, like take the top of the card and reveal it and take it out of the deck. Okay, and if there are still cards in the deck, then put the next top card of the deck at the bottom of the deck. So same thing we have to follow on our indices double-ended queue. Same thing we follow, so that we will whenever they are revealing that thing, they will get the this output. So whenever they are revealing, so in that case they will get 2 in the order of 2, 3, 5, 7, like that. So similar thing we have to do in this case. Okay, and whatever the face indices we will get, so we will put it into our result. Okay, so we have to take the each of the element, and whatever the indices we will get from that operation, like there are two steps, like checking the top of the deck, then reveal it, put it outside, and then checking the other next front, and that thing we have to put into the bottom. So that thing we are going to do on this double-ended queue. So first is 0, so the first element in sorted deck we put into the index 0, 2, and we are now copying this 0. Okay, I have just removed, and whatever the next element, we have to remove that thing, and we have to push it to the end of the deck. Okay, so whatever the next element, so this is the front of the double-ended queue. So at the index 2 we have to push the next element. So 3 we need to push at the over here. Okay, then we remove this, and we have to remove 3 also, and push it into the back of the deck. So whatever, so then next indices is 4, so we will put the next element, which is a 5, we put at over here. Okay, at fourth index we will remove this thing, then we remove 5 and push it into the end of the deck. Then at the sixth whatever the next element, which is 7, we have to push it and put it into the sixth index. So 7 we will put into the that index, and then whatever the 1 is there we will put over here. Okay, then there is the next is 3. So at 3, the 7th next is 11. So 11 we are going to put over here. Okay, so at the third it is there, and then we have to pop this and push it into at the end. So at 1 we have to do at the 30. Okay, so now it will look like this, and we have the only 5 in that, and so remaining the 11 we will put into the 70, and that gives the us the exact result, like 2, 13, 3, 11, 5, 17, and 7. What is the output of our, so what is the expected output of our, so yeah, just let's write that code over here. So what we required, like we required one result array, right? And just we will initialize that array with the 0, and size is having the same size of the dick. Okay, then what we can do, we have to sort the first thing, like what we have did over here. We have first sorted our dick, so we need to sort our dick. So we'll sort our dick dot begin, comma, dick dot end. Okay, then we need to use the double-ended queue. So what we have to do, we have to insert the elements indices into the double-ended queue. Okay, it should be less than dick dot size I plus plus indices dot push back will do I. Okay, so we have post each of the element in the indices. So this initialization of our indices dq is done, right? So let's do the result array, what we can do. So in that case we are taking each of the element, and whatever the dq's front element, we are putting it at that location. So we got first 0 and we have put at the 2, then we have pop the 1, push it into the end of the day, and then we have the front indices as a 2, and so the next element we have put it into the second indices. So similar thing we have to do over here. So for that I'm just going to do at a value of the deck, and deck is already sorted, we have did in the earlier line number 5. So now what we have to do, result of let indices our deck front value, we will put into the, the value, whatever value we have got, we have to do in that. Then we have to pop that thing from the front. Then what we have to do, we have to push the next element into the end of the deck. So let's just start front, what you have to do, and the first element is already currently present, so we have again pop that thing. So whenever you are getting this thing like 0, so first you have pop this thing, then whatever the 1 is there we have push at the end of the deck, then we have to pop the 1. So the next is like 2, 3, 4, 5, 6, and 1 will be there in our double-ended queue. So this will give is our exact answer. So we have to return result as our output. So yeah, so what, yeah, so our code is done. Just let's run. So I will explain, like we have initialized the result with the size and having the 0, we have sorted the deck, then we have used double-ended queue and indices in that, and we have pushed back all the indices in that. So that means our indices double-ended queue will be got initialized, and we have take the each value from the deck. Okay, and it is a similar for loop, like for integer I is equal to 0, like what your normal for loop you have used. So this is the one of the advanced C++ we can used over here, dot size, and so this thing also you do, and how you have accessing with the deck of I, like that. So over here it is directly accessing through value, and each iterate from means from 0 till the end of the index, each of the value from that deck, and whatever the indices front is there, we put our value in that indices, then we are popping front, then we are pushing the front value, that is the next element they have mentioned, like next top card of the deck at the bottom of the deck, and we have removed it from the front, and that gives us our result. Just run this code and let's see whether it works or not. So it is working, so both of the test cases got passed. So let's submit this code, and this is we are doing in the order of n complexity. So I think this is the most optimized solution. Yeah, and for the sake of simplicity you can also check like what will be the what they have did in for the highest complexity. So they have did the similar thing like sorting, then initializing the queue, and popping, pushing, that thing they have also did. So our code and their code is simple, I mean same. we are doing the same thing and complexity is same, but some of the cases means lead code is giving the different values. So let's say if I submit once again, then it will give the different runtime. Okay, so you have to check according to that. So it is now giving the different runtime, but this is the most optimized solution. I hope you have understood this question. um, let's check our website also, that is www.learnitor.com, and check the various blogs and the solution for this code and that. And thank you for checking this video. Thank you very much.